Okay, we're back live. Hi. Heck of a day yesterday. So we got some results to look at, and they're not great. They're not terrible, but they're not great. So we have this Pareto from right here, right? This is what carbs is producing. Each of these points should be a very, very accurate estimate as well, based on what we're doing. So these parameters are fixed. Entropy looks like it has a good spread. Are these all the same? I can't tell. 97225. Oh yeah, it's resampling right here. So all these runs are the same. Wait, but then they shouldn't be this different in terms of their performance. Let me look at something. Gamma. Something's weird here. This dashboard's a little jank. No runs. Do I just do this offline? I think I could just do this analysis offline. This would be kind of heavier. Yeah, I think that's what we're going to do. We'll figure out a little bit of analysis offline. I want to see what's happening with carbs here. This is not what the algorithm should be doing, I don't think. This is not great performance. I don't know if this is carbs being weird or somehow the usage of it. But I'm going to do this on my main box. Okay, we're on the right branch. And now okay, we got correlate here. We got correlate. We're gonna mess with this script a little bit. Where's our? Let me get this set up. So this is carbs breakout full. Carbs breakout full. Threshold is going to be, say, 200. Interesting. Environment slash. It should be environment slash score, right? Ah, you gotta do dash dash refresh. And this environment variable. Okay, so we have our data, 180 runs, 5 good runs. Hold on, something's janked there because I see way more than 5. Way more than 5 runs here, right? Is it 200, right? Yeah. Okay, so let's look at this. Okay, well that's bizarre because that's not what I see on the table. It's not what I see on the table at all. $178 runs. Carbs breakout full. Look at all these. Environment score. Oh, that's a problem. Ah, all of my charts are wrong. All of my charts are wrong. Last. Okay, so that's user error. So the reason that we're doing this as well, the last point that Puffer provides is always a very, very good estimate. Because the last point that it submits is an eval point over a lot more data. The max is going to be much noisier. The thing is, though, carbs should be correctly using the last point as a stable estimate. But this should explain some stuff, maybe. Okay, so now we can see that there are actually only like 1, 2, 3, 4, 5, 6 points above 200, it looks like. And if we look at the Pareto front, yeah, this is more reasonable. We can look at curves for this as well. So this is right here. These are very, very noisy curves. This environment in general, I mean, you can see the train curves are really all over the place. I wonder now, why is that? Is it the reporting interval? It can't just be the reporting interval. It actually has to be something to do with the dynamics. Because even like if you were to smooth this, right, this is still all over the place. All these ones down here, these experiments at the bottom, we're going to implement early stopping today. So these should just be removed, basically. But the charts are a little laggy. I'm not going to lie, Neptune. Your charts are a little laggy. Better than want to be, but still laggy. Okay, so here's our data. What else do we want? This dashboard. Okay, so there's sections. This is just, I'm a little confused as to how this is getting sorted because like I keep trying to sort these and it keeps undoing my sorting. Let's do sweep cost. Cost. X-axis is going to be time. Where is this? It's creation time. And Y is going to be the actual cost. Where's it? Performance uptime last. So here's our sweep cost plot. You can see that this is not really doing the thing we want, which is biasing towards longer and longer runs. There are some things I think we should look at for this. I'm especially suspicious of this point that's been resampled a million times. $94.70. So 97225. What key switches do you use? Razer, what is this? Razer Black Widow 75% with orange switches. They're the clicky but not too clicky ones. I like my Razer keyboards. They keep actually improving them every generation as well. Like, the keyboardists have gotten noticeably better each version. They don't just like sell you the same thing. It's got like a really nice metal, like nice cool metal frame on it. This wrist pad's gotten way better. This is super solid and really nice to type on. Keys feel better. Layout's gotten better. I'm sure some like mechanical keyboard enthusiast will tell me that this is garbage, but it's pretty damn good keyboard to get if you don't spend all your day on our mechanical keyboards. I kind of just do all my peripherals from Razer because they're always solid. It's just Apple for people who hate the Apple aesthetic. I think Razer has orange, yellow, and green. The yellow ones are like linear and silent. The orange ones are like quiet and tactile. And then the green ones are the obnoxiously loud ones that makes everyone hate you. Also, good morning, Captain. Bright and early. Oops. What just happened here? At a terminal. There it is. Used to being in a room with people. 4+. Oh, geez. That's just obnoxious. There's no reason to do that. Like, if people complain that you have tactile switches that are quiet, it's like, whatever, but... I had, my freshman year of college, I had a roommate from hell who had the world's loudest mechanical keyboard and would just play Osu until like 2 in the morning. And, I mean, he hit those keys so hard that he had to switch the keybinds because he broke a couple of them. You could literally hear it with the door closed, down the hallway. It's god awful. Okay, so this is insane. I really wish I could just see this in the Neptune UI. I mean, I know I'm gonna have to build out our plot stuff more. I was hoping to avoid doing that initially. Something's really broken here, though. Let me see if I can figure out their UI, because this would just make it easier. So, okay. Search runs or build query. So we do gamma last greater than. Do you have and? This is the wrong variable, maybe? Oh, there it is. That's weird. Hello, I come here every now and then because I think your work is so fascinating. Thank you. We're currently just doing a little bit of work on these hyperparameter sweeps. We got carb set up to automated just tune all these environments and experiments automatically, but it's not quite doing what I want it to do. So carbs has this property where it's supposed to be able to start off doing fast experiments and then run longer experiments once it becomes confident of the result of those, and that does not seem to be happening. So yeah, hyperparameter stuff is just really, really important generally for all of Puffer because it kind of makes everything in RL just work faster, better, and easier. And then also any research that you do on top of that, all your experiments run faster. So hyperparam is like very, very important. If you're interested in getting involved with the RL stuff, by the way, it's pretty easy. We've got a fun Discord with a ton of people in it, and just lots of people building all sorts of RL environments. Many of them came in with no prior RL experience. You just need to know how to code. Like, here. This is built by a contributor, this is built by a contributor, this is built by a brand new contributor, these two are built by new contributors, all these are built by contributors. I mean, really the only ones of these that I built two of the more complex ones, admittedly, Neural MMO3 and MMO, and then I built this multi-agent snake. I mean, obviously I run infrastructure for all this, but most of the ends are by contributors. I think I got parts of what you mean. Well, I mean, if I say it simpler, right? So there are a bunch of knobs for reinforcement learning experiments that affect whether your runs are going to be good or not, whether you're going to learn well or not. And you need a way to automatically tune all these knobs. That's what hyperparameter tuning does. So what we're currently doing is looking at one very good algorithm in that space, and we're seeing whether that algorithm has the properties that we would want it to have in order to be useful for the types of experiments that we want to run. Okay, there we go. Now can we do gamma? Data scientists more intrigued by RL and genetic algorithms. Genetic algorithms aren't really used for training the agents, but they are actually used in hyperparameter search. So there are successful implementations of genetic algorithms for hyperparameter search. And generally the reason for that is that the RL models have at least 100,000 parameters, sometimes millions or tens of millions. Hyperparameter tuning algorithm is going to have between 5 and 20 parameters. So like 20-dimensional space is about what you can operate on with genetics. Now I will say that it looks to me, and I'm not super familiar with this space, but it looks to me like Gaussian process-based approaches have been outperforming genetic algorithms for a while. I implemented a really simple genetic algorithm as a baseline and did okay. I think the Gaussian process-based ones are doing better at the moment. Perfect, there we go. Yeah, we caught it. Gaussian, yeah. So the algorithm that we're using at the moment, this is a very good algorithm, at least from our tests. It's imbue carbs. We have our own fork of it, and we have our own little tweaks to it. But it doesn't seem to be behaving exactly as we'd want it to. And now this is a very weird quirk right here. So it seems like it launched the same experiment a bunch of times. Personal question, where are you based? I'm a resident of Florida, but I usually spend a few months of the year in California. I mean, all this stuff is remote. It kind of doesn't matter where I do it from. So I spend a little time in California because there are a lot of people to meet out there, travel a little bit. But for the most part, I do from wherever. I just work from wherever. There might be a little bit of moving around soon because we're getting, we got to buy more hardware and I'm going to have to maintain that. Oh. All the sunny places, yeah, pretty much. I spent 5 years in Boston for my PhD, and I'm sick of being cold. Welcome, YouTube folks. So I have no idea what Carbs thinks it's doing here. This is very, very weird to me because I'm pretty sure all these runs are the exact same. I guess I could add, hold on, new widget. So we're gonna do morning. What are your carbs params? I'll show you in a sec, Captain. So this is a bigger carb sweep in which we are doing batch size and stuff as well. But the thing that we're trying to get to work right now that is not working is carbs should be finding longer experiments over time as it gets more confident. I'm in seal. Yeah. That's why the time zones, I guess. It's 8:36 a.m. here. Okay, interesting. So I don't know what's up with this data point. I think this is just like randomly happens to be very close. This purple one. Yeah, something's weird with this point, but whatever. So if we look at all the other points here, yeah, see you around. If we look at all the other points here, is this really the variance from random seeds? Gaussian processes, yeah. It's in the carbs paper. Hebo as well is like another optimizer based on there are a lot. Okay, so this is very concerning. So look at this. Unless something is deeply wrong here, these are all supposed to be the same hyperparameters. Hi, welcome. Let's say yeah, welcome. These are literally supposed to be the same hyperparameters. Is it really possible that there is that much variation from seed to seed? Well, they're not supposed to, but look what carbs did, right? Look what carbs did. So I put this filter on, and carbs has sampled the same parameters like 38 times. It really likes these parameters for some reason. We can figure out why that is. But for now, it did do this, okay? Are these insane hyperparameters? 005. I don't think that these are insane hyperparameters either. 94, 97. Yeah, these are like pretty reasonable. Oh, learning rate maybe is a little high, but these are pretty reasonable hyperparameters. So we have 30. I mean, I think these aren't getting applied correctly, but I think that they are getting applied correctly because look at this. All the runs, they take almost the exact same amount of time. So, num-m's, batch size, all these things. I should add batch size to this chart. Num mini batches. Yeah, that's a glitch with carbs. But like, ignore the fact that that shouldn't be the case, Captain. Ignore the fact that it did this for some reason. The question is now why the results are so dramatically different if they're all the same. So basically, this bug is gonna let us find out something else that's weird, right? Okay, so look at this. So we have sampled here. This is sampled 4 mini batches. So all the exact same hypers. And to be fair, there is carbs has a resample function that it could just be calling too often. Every 5. I think what's probably happening is it calls resample, and it's probably just always resampling this point instead of resampling an arbitrary Pareto point. Yeah, that's probably what I'm going to do next, Captain. But I mean, there's something screwy here. So look, these are all the same. Okay, the other possibility is that these are just bad hyperparameters that induce a lot of variation from run to run. So we have these charts. We can see these are all over the place, right? These evals at the end are accurate. So here's a cool thing, right, with Puffer. You see how there's this line is very long here? That's because this point at the end is an average of this many samples. So this is E plus 7. Yeah, so this is over 10 million. Over 10 million. It gets at least 100 log points, which is at least 100 environments worth of logs, but in practice is going to be way, way more than 100 log points. And it'll keep running like this for if whatever reason here, if it takes longer to get enough logs, it'll keep running. So it's almost weird that it's almost weird how they finish at the exact same time. Maybe not, because it goes by batches. I mean, you can just see how dramatically different these curves are, though. The next thing to check is going to be charts. It's going to be the losses. So our clip frac is not terrible. We can see entropy is all over. Policy loss is reasonable. I mean, these don't look terrible. The value loss is not good on these. Maybe there's a problem with puffer and value loss because now this is 3 different environments where I've seen value loss be screwy. But I'm trying to think how that could even be the case, right? How could puffer have a problem with value loss? Could it be our GAE? We can definitely do the Pong runs next. Do we have any M's that can compare? Yeah, certainly. It's just that the other implementations are way slower. I mean, we've done this over various times in the past, right? Like we have parameters. I mean, I guess maybe it's worth checking them, but we have parameters for like classic Atari games and stuff like that. We've tuned them a little differently in Puffer to make it faster. You know, the vast majority of RL repos out there are just painfully slow. Sanity check value loss. Yeah. I mean, that's the only thing that's suspicious, but it is, I mean, it is possible that there's just this much run-to-run variation. Well, this tells you why, I mean, we can't fault carbs. We cannot fault carbs for this. I think I think it would be worth coming up with a good synthetic test for carbs. Yeah, I think it's worth actually investing a bit of time coming up with a really good synthetic test for carbs that includes the cost-aware component and that kind of simulates how simulates the trade-off with update epochs and batch size and stuff. Because I want to make sure that carbs is performing the way we expect. And that any variations, basically I want to have the utmost confidence in our hyperparameter tuning. I don't want to have to think like, is our hyperparameter algorithm not amazing? I want our hyperparameter algorithm to be like known amazing and the settings for that to be known good. And then I want basically to isolate all of the problems to the RL algorithm side. I think that's going to be the best thing to do right now. Yeah. Because I can actually see, you know, carbs could be fine here. With this much variation, even across runs, right, it's very possible that carbs is not running longer runs here, right? It's just not running, where is it? Sweet cost. So it's just not going to run longer experiments over time because it's not confident in the outcome of the experiments. Right? Carbs has a predictive model of performance, and it is set up to run longer experiments as it becomes more confident in the outcome of the cheaper experiments. But if there's this much variation, then it can't predict anything, right? Then it's going to regress to something that's only going to be a little bit better than random search. Seen it stop? Yes. So now the question is whether this is a problem with carbs or this is a problem with our evals or the environment or like stability or something else. Also, hold on. Where's our random search? Because I found a bug in our breakout stuff. Not this one. Okay, we're still good. We're still good. I had the plots misconfigured so that it was showing the max score instead of the last score. But we still have carbs here with solving the environment. So we can solve the environment. time step param space. So right now, Captain, I have centered at, it's a log function, centered at 100 million, that can go from 10 million to a billion, and the standard deviation is a quarter of an order of magnitude. So whatever that is in log space, what's a quarter of an order of magnitude? I actually don't know how to do that transformation in my head. 1 order of magnitude would be it like samples at 100 million, but then standard deviation could be 10 million or a billion. It's a quarter of that in log space. Gotta go. We'll be back soon. Cool. I'm gonna work on this a little bit. I want to make a synthetic test for carbs. I want to make a good synthetic test for carbs. Okay, so this is what we had before. So we're going to do synthetic carbs simulates out of an RL experiment roughly scaling thinking there's okay. Score cost Hey Spencer, let's see. What do you have for me? Ooh. Check sweep, reward. Where's success rate, Spencer? Do you have environment solve rate? Never hits the final goal. Okay. Let's look at this for you. How many rows are there? 8. Well, this is nice. These curves are nice. This junk over here is carbs definitely being weird. Let me show you, by the way, real quick. When you say you have to set up Pareto front, you literally just do this. Well, if the fucking UI doesn't break. God damn it, Wanby. So their UI is broken. So literally all you gotta do is click that thing. It's not working on mine, but that will give you the Pareto front. Looks like your reward tuning matters a lot. Look at this. You see this reward tuning seems to matter a lot. So good job doing that. Let's filter. These are like ridiculously clean curves, you know. These are ridiculously clean curves. I'm surprised it doesn't jump up. You know, this is the type of environment where you would expect it to like jump up in rows. So, I mean, here's the other thing I can show you, right? This is the other thing I can show you. Is that if you just keep training it, like probably it'll go up more. If you just take one of these runs and keep training it, it'll probably get to 5 at least. You're only training it for like 3 minutes, man. Policy. What policy are you using? Link policy code. As soon as you finish this, I'm gonna help onboard you to science side stuff if you're interested in that. So there's your motivation. And I could use the help on the science side as well. That's really the valuable thing you can train people in. Blanket puffer policy with OSGM. Is this the default policy? Wait, is this the default policy? Can you link me this, Spencer? I want to take a look real quick. And then I want to finish this carbs thing. I on a tight schedule. Not really. It turns out there's a lot of time to dev if you do literally nothing but dev. On mobile, let me see if I can find your thing. Oh yeah, here it is. Is it just this branch tower climb? Config. Oh geez. Yeah, man, this is a shitty policy. I'm surprised it does anything. So like literally that's just gonna flatten all the data. I think you should probably, I mean, these experiments are now quick enough that there are a couple things I would do. And actually, you know, this will be good for you because this will help a little bit on the science side for you as well. So carbs is great, but the problem is carbs takes a bunch of experiments to get off the ground. And eventually we'll have like nice ways of warm initializing it and stuff before even thinking about action masking, man. So, because yeah, that matters a lot, but it looks like your reward's doing fine here. You could log like illegal moves, like you could log like num illegal moves or something. That would be a good idea. But I wouldn't mess with that just yet because that's going to be trickier. Damn it, I lost my train of thought. Hold on. Right. So this is what I would suggest doing. Okay. And this is where I had all those Neptune plots come in. You actually have a fair bit of good data here, right? So this is what you can do. And it's annoying in Wanvi, you can't really download your data to do this automatically. But this is like science side stuff that you'll probably want to get involved with. So like, let's take your learning rate, okay? Trained out learning rate. And then on this side, we're going to have, where is it? Towers, rows, cleared. Okay? And we're going to take this filter off. And now, I'm going to put this. Okay, perfect. So you see this right here. This tells you that for your environment, all of these runs to the right, these are all wasted. You can see that the stable range for experiments for you is this very, very low learning rate, 0001 to 0012 or whatever. So what you can do is in your sweeps, right, in your sweep configuration, and you might have to go grab my ablation branch to get like the new configuration to make this easier, or it might work in the old one, I don't know. You can restrict your learning rate sweep, right, to a generous bound in this region. So this is like 1e minus 5 or something, or 1e minus 6. You can go from there, maybe even a little lower, up to whatever like around here is. And then your learning rate will be a stable selected parameter. And then you can do the same thing. Let's look at gamma. Okay? So gamma, you can see all your gammas are from 0.9 to about 0.96 or 0.97. So you can set the range for that. Right? You can set the range for that. And then you can do JE lambda. And here, again, 9.1, 9.7 maybe. And if you do this, what's going to happen is that even your random search, even if you just run random search, you're going to get good experiments quickly because you're only sampling within the relatively stable range of hyperparameters. So basically, you're going to increase the speed at which you can run all of your experiments on this. And then once you do that, you run a quick check to make sure that your random sweep produces you, decent runs quickly. And then you can go rerun either random or carbs with those nice new ranges, those like initial ranges, with new policies, right? And you can use the new policy that I suggested, which is the 2 layers of Conf3D into the LSTM. Now, does that make sense? You see how much easier that is than like messing with action masking? And you can just see on this graph all these ways to do experiments. You see how that's going to so quickly give you a lot of return on investment? Some of the params have a logic check, forces the value to have min 0. Min 0? It shouldn't force it to have min 0. You should be able to increase the min, and if you can't, then that's something that we have to fix. You should check both the demo in 2.0, but also check my ablation branch, because I've made some nice changes there, and I made a few additions to carbs. But do you see how something this simple is likely to just dramatically speed up everything that you do? This is why I spend so much time on hyperparam sweeps and stuff, right? Because if I'm looking at how do we make RL consistent and stable, this is the first obvious place that you look, and you have the data to prove it. Analyze each hyperparam for good rain, run better sweeps, and then improve policy. Yes, exactly. And let me know if you need help with the policy, but it should be very easy. You just got to make sure, the only thing you got to make sure is that you don't blow up. If you implement your policy and it goes to 2 million parameters or something, then you've done it wrong. But there you go. This exact type of thinking, by the way, this is the type of stuff that I'm going to want to show you to onboard you to science side stuff. Because it's I'm really not a genius. It's very basic stuff like this that allows you to make huge amounts of progress. On writing the other policy? Yeah. So write the other policy, but don't throw away most of your experiments. I mean, if you really want to write a policy and just run the same carb sweep on it, you can do that. It's just going to take longer. But yeah, technically, if you only have an hour to work on this, right, then yeah, I'd probably just do the policy as well and overnight the experiments, because it'll take a little longer to think through and get the hyperparams right. But you definitely want to do both of these things. And also, this is a major thing with Puffer, is we're going to want to basically have the ability to make it easy to get the ranges, the hyperparam sweep ranges for your individual environment correct, so that when you run all of your experiments, you're only exploring in the stable ranges, and we want to automate all that stuff. There you go. If there are no other questions, I'm going to go back to this synthetic carb shenanigans. I want to get better at writing good policies. Yeah, you can do that, but the thing is, like, I think that you think that there's a lot of magic there, and there isn't. Like, there's really not a lot of magic there. Like here. This is neural MMO3, all right? So this is what I made in order to make, in order to do neural MMO3. That's the whole policy, right there. It's got some 2D comms, it's got a discrete encoder, it's got a multi-hot. The only tricky thing here is this factors trick for multi-hot encoding. But like, dude, look at this. That's it. That's the policy. And I had all sorts of more complicated policies that did worse and were slower. Doesn't take a lot. There actually might be like a bunch of alpha in policy search type work, but the thing is, you're never going to find it manually. Like, when we do architecture work, it's going to be automated work that's supported by really good fast sweeps, right? And like here, let me show you something as well. I think I've talked about this before. This is the last thing we need to do for now, and then I'm going to go back to this sweep stuff for an hour. But okay, so I think a lot of like the motivation to like try to get good at policies, it comes from stuff like this, where it's like, oh man, look at the policy that was used in OpenAI 5. Like, this is a complicated policy that was written by people that really know what they're doing. And yes, but the thing is, structurally, the reason that this policy is so complicated is because Dota has a fancy state space that needs to be parceled out, so you're not just putting it into a flat encoder. The core of the entire network is this LSTM right here. That's where like almost all the parameters in this entire network are in this LSTM right here. And then these are just action heads, right, for the different actions. Some of these are multi-discrete. Most of these are discrete. So this is just a multi-discrete decoder. Like, this whole block, except for this one attention thing, is literally just our 3-line multi-discrete decoder. This unit attention keys, this is a little trickier. I can explain this, but basically this is what happens when you need to select a unit that you can see rather than picking from a fixed list of things. And then all this stuff at the top is just an entity encoder. This is just like a specific subnetwork where it's like, hey, the unit has this specific hero has a type. Let's embed it. We want to know whether you're currently attacking. Let's embed that. Health, attack, region. Okay, we'll embed that. And then they do this for everything. And then orientation. Okay, we'll cosine and sine embed this because it's an angle. And they just concatenate everything. And this is literally just like a 2-layer MLP. And then over here, they do the exact same thing with all the abilities and modifiers. So like, this almost isn't even network design. Like, there's very little required understanding of like neural network architecture. Literally all this is understanding the structure of the data coming out of the environment and how to sanely get that into a flat vector. That's all this is. And then this thing here is like a janky, this is like a janky multi-headed attention before multi-headed attention existed. But whatever. That looks like this, that looks like that is setting their obs. This is encoding their observations. But if I explain it that way, like, you don't need, like, there's no knowledge here to know that you can do a 2-layer MLP, right? Because the actual network, this is a two-layer MLP, this is a two-layer MLP, this is a two-layer MLP. Why do you use max pooling? Use max pooling because you have a variable number of entities and want them to be encoded the same way regardless of what order they're in. Okay, that's it. Like, very, very basic things. And yeah, there's like this weird concat where they FC relo. This is just like a multi-headed attention shenanigans thing. Not really a huge deal. And that's it. That's the whole network. So this is like the most, like, as complicated as stuff gets. And the only reason this is so complicated in the first place is because of the structure of the observation data. Like, you don't need any of this because you don't have data that's this structure. Like, this won't help you because you don't have data that structure. So that's the knowledge part. I'm gonna write this next. I'm gonna write this synthetic search, and I'm gonna get some breakfast. I'm hoping I get to start running again next week and stop being a blob. We're gonna see how screwed up my lung capacity is. I definitely am not going to be able to run a 5K. I'm hoping that I'll be able to run a couple kilometers without dying. Help with science once I get towered climb. Yeah, exactly. I think that that's a good plan. Is like finish this environment up. I'm kind of feeding you little bits of the science side thinking as you're doing these, and I'll onboard you once you got that set. A lot of it's very basic science work, but it's like very effective science work. So we gotta figure out how to model this. We're gonna model this as base or gonna be 100 times plus wait, minus, this is negative. So this is negative. And then, well, I don't like this actually, because this is not going to be, I don't like that this peaks at 0. Anything about this? I can just add 1, right? Yeah, I can just add 1. Okay. So these are our parameters plus 1. So this gives us base score maxes at, so base score maxes out at 1. Okay? And now we need to modulate it. Mod SQRT of let's do log 2 batch size times square root of num many batches. Oh no, this is total time steps. Okay, and then it's batch size is going to probably be a square root times square root batch size. And then this has got to be divided by I just need some base number. Let's do 60. Is 2 to the 4th, right? I'm just being stupid. No, I'm dumb. Okay, 8th. 256. 256. Oh, and then I got to do total time steps. This has got to be divided by numpy log 2. Okay, and I can actually just do numpy that's 6, 5, 6. Okay. And then times square root of num mini batches is fine. Update epochs. What do we treat this as? Same thing, probably. Update epochs. And then the only thing I haven't accounted for is num ends. I have not accounted for num m's, which, do I model this in here? More m's being worse. I think I leave that out for now. So this is your score mod, then cost mod. You also need a cost mod. Hang on. Okay. Cost mod. Well, this one is easy, right? This is just going to be total time steps over 100. And this is 100 million, not 100,000. Okay. And then this is going to be mini batch size over the base mini batch size, which we'll say is 16K. Wait, no, it's other way around. Cost mod. Num m's. times update epochs. Mini batches like this. And anything else that affects this. Update epochs. I think these are all the parameters. So we'll just put this in cost. And now what we should have is score is base score mod times base score. And then we should be able to return score and cost. Okay? And now what we get to do is late mode test carbs. And then we do Neptune tag sync carbs. We'll fix whatever needs to be fixed. Maybe it just works. Perfect. Now, it's a little slow because it's going to do a Neptune connection per. But I'm just going to let this run. We're going to probably have to tweak this a little bit, but we're going to see what happens with this. I'm going to be back in, I don't know, about 10 minutes. Do a couple quick things. We'll check on this, and then I'll go to breakfast. But yeah, let's see. I wish I could make this auto show so that it'll show the new points while I'm away, but I don't think that'll work. So, anyways, be right back. Okay, we're back. Look at that. So, sweet progress. It very quickly gets up to here. And then sweep cost. Where's cost? What's up with this? Pareto front. I mean, this is like what you want here. Sys running time. Oh, wait. No. This is not all right. Because, yeah, this is not the thing that it's actually getting evaluated on. Let me see. So we're going to do static cost. And then this is going to have on the x-axis, what we're going to do is time. Creation time. The y-axis. Well, no, that's not the right thing. We want to do on the x-axis, we want to do cost, which is uptime, do we call it? Environment / uptime. Oh, maybe this is right. Hold on. No, it's not. Yeah, we need to add environment / uptime. Okay, so this is going to be last. Then y-axis is going to be 4. Okay, add widget. Okay, so here's our synthetic front. This is very weird. So it's possible that I messed up the test, and it is possible that there's something with the carbs. Let me see. Synthetic carbs observation, score, and cost. Let me see if I got this right. So this is a multiplier, right? Score mod. You should be able to get so if you set batch size to here, you should be able to get over 1 quite easily, right? Let me see. So learning rates now, it should be at 0.001. So over here. So you got the wrong learning rate. And gamma should be 0.99. Okay, this is where gamma is. It's like using all the variables here, but environment score. So it gets up to here. So something is off, I think. This is with no noise as well. This should just be able to shred this baseline. Is it the cost component that's messing with it? Because like clearly this is not what we want. Let me try something else. We do no cost. So we'll keep the score mod, and then cost is equal to cost equals 1. So they all have the same cost now. And we'll run that, and we'll see if the errors are coming, or if the lack of optimization is coming from carbs not correctly handling the cost trade-off the way it should be, or something else that I'm missing. So this will run pretty quick. It's about 10. I'm gonna go get some breakfast, take a quick walk, and I will be back. Hopefully I'll be back in like an hour. I got a meeting at 12. Hopefully I can do a short just analysis thing before that. But if not, I will be back in the afternoon on this. This is like pretty basic hyperparam stuff here, but this is going to be the basis of a lot. Pretty much at the moment, there are too many sources of error in RL. The algorithm, just seed variance, tons of stuff. So really what I want to do is I want to have a synthetic test that convinces me that if your samples coming in from the environment are good, that your hyperparameter optimization is going to be solid. And yeah, I think it's worth spending some time on that. For folks on YouTube, and join the Discord, discord.gg/puffer. You can check out live demos of all of our RL stuff on puffer.ai. It has links to everything. If you want to help us out for free, start the repository, it really helps a ton. And you can also follow me on X, where I post lots of RL stuff.